Okay, guys, today inshallah we're gonna start in chapter 22, section 1. So we already done of section 1 and 2 of chapter 18. We studied the equilibrium and how the equilibrium could be shifted and how we could find the K or the equilibrium constant. So we're just gonna pass to another branch of chemistry or a new topic of chemistry, which is the organic compounds. So we're gonna study all chapter 22, and like this we end our material inshallah. So let's start by the first section of chapter 22. In that chapter, we're going to talk about the organic compound. So what is organic compound? Anyone have idea about what is organic compound or what are organic compounds, guys? Do you have any idea? Or you heard this word before? Or what's your expectation from the name? What is organic compound, guys? What do you think? Just raise your hand. Yes, Hassan?
بس تقريبا اللي هو كومباوند بيبقى فيه كربون.
So a compound that contain carbon gas, but actually, Hassan, I need to ask you, the word organic compound does it reflect that meaning? Organic compound. That means once you hear organic compound, is it somehow this word related to carbon at all? What do you think, Hassan?
نو.
No. So that's the point here. Actually, the word organic compound in the past, okay, scientists classified them, or people thought that organic compounds, they are compounds which are formed inside living cells, okay, or inside living organisms. That's why we call them organic compounds. But actually, later we discovered that there are some organic compounds that can be formed out of living organism or out of living cells, like methane gas, for example, okay, or something like this. So that's why, okay, this definition was not that accurate or true, and they start to define the definition of organic compound to be compound that contain carbon. Because actually, all organic compounds they are mainly or they are based on carbon atoms. That means all organic compounds they are made up of carbon atoms. But actually, not all compounds that include carbon considered to be organic compounds. For example, the carbonates like Na2CO3, like K2CO3, sodium carbonate, potassium carbonate, whatever carbonates, okay, carbon monoxide, carbon dioxide, they are compounds that contain carbon, but they are not organic. They are inorganic compounds. So like this, we modified the definition to say that organic compounds or the organic chemistry, they are the chemistry that study compounds that contain carbon except carbonates and oxides. Okay, carbonates and carbon oxides. Okay, is it clear here, guys?
Yes, Mister.
Yep. So like this, okay, science start to find or to study these organic compounds, and actually we find that the organic compounds, there are infinity of organic compounds, different types of organic compounds with different characteristics. Okay, so what makes this huge diversity of organic compounds? Why we find this variety? Actually, that's because of the carbon characteristics. Okay, so what makes the carbon able to do this? Because we said that actually the carbon structure, as we know, carbon. If anyone can remind me, what is the atomic number of carbon? Anyone remember? What is the atomic number of carbon? Carbon C6. Okay, so as at C6, if we make the electron configuration, so 1s2, then 2s2. Okay, 2b2. Okay, so here regarding to this electron configuration, this unique configuration as in second energy level, there are two energy level in the sub energy level S and two electrons in the sub energy level P, which are they are too close to each other in energy that allow kind of hybridization that happen between S and P, which allow the four electrons in that outermost energy level to be involved in a reaction, which means the carbon now is able to make a four bonds. Okay, so each carbon atom or each single carbon is able to make four bonds or bond with four different elements or even similar elements or whatever. So that's make that carbon has a kind of ability to make or to create a huge kind of elements based on how many carbons are being involved in that compound. And also carbon atoms they could bond it to another carbon, okay, creating a long chain like this, okay, so and so on. Or it may, okay, they create rings, okay, like the carbon they could bond together, okay, like that, creating rings, okay, and so on. So here that's lead to diversity. Whatever we have a very long chains of carbon or rings or something like this. So the different arrangement and the different elements that we could be involved in an organic compound, okay, they are limitless. So that's why we find this diversity of organic compound. To get more about this or to know more about this, let's see here, guys. For example, here this analogy or this picture actually is magnificent. Okay, this picture represents that the organic compounds that really surround you and everything. So the fruits, the vegetables, whatever you eat, okay, that's organic compounds are there. The plastic papers, okay, and so on. Also, the organic compounds here, even the tablets and the medicines you are just intake in certain conditions, they contain organic compounds. The hair and your skin, your tissues already, or your cells, they contain organic compounds. And as you observe, some organic compounds are just long chain of carbons. Some of them, okay, they have rings, okay, like whatever here in the aspirin. And some of them, they have branched, okay, or zigzag chain. Some of them are combination of two rings, okay. So like this, we have this diversity of organic compounds. So first of all, we could find that the carbon atom is able to bond with another carbon atom, okay. So that means here we could find a carbon atom that is able to make a covalent bond with another carbon atom to create a long chain of carbon and this or even a ring, okay. So that's here we call this, okay, okay, satination. Okay, what is satination? That means the covalent bond of elements to form a chain or ring, okay, of the same element. That means once an element is able to combine to itself to create a long chain of that element or a ring of that element, okay. So that's one of the reasons which make, okay, the carbon able to make this diversity of organic compounds. Beside that, carbon could bond to another carbon atom with a single bond or even double covalent bond or even triple covalent bond, okay, that's lead to a different or more diversity. That means sometimes, okay, we have carbon connected to carbon with single carbon or a single covalent bond, or carbon connected to another carbon by double covalent bond or even triple. That's what you lead to diversity. We are going to learn about it in next section, inshallah, when we talk about hydrocarbons. We have alkane with one single bond, okay, alkyne, okay, with that's two double bond, okay, and alkene, okay. So that's here, that's alkene double bond, okay, and alkyne triple bond, and so on. So we're going about this later, okay. So let's just keep here in our lesson. Also, we could find that carbon, beside that they are able to bond to each other, they are able to bond with another element, okay. The most common element beside hydrogen, okay, in or any organic compound is hydrogen. That means there is no organic compound that just contain carbon only, that must contain carbon and hydrogen. So here we could find that hydrogen is the most abundant element in an organic compound, okay, because like this, each carbon is able to carry up to 4 hydrogens, okay. So like this, we said that hydrocarbons, that the simplest form of organic compound, which are just contains carbon and hydrogen only. But actually, carbon is able to bond with other elements rather than hydrogen. So that means inorganic compound basically contain carbon and hydrogen, but are able to carry another elements or to be include another elements, mainly are nitrogen, phosphorus, oxygen, and sulfur, okay. So they are the most common elements, okay, that could found in organic compound. Besides some halogens like chlorine, fluorine, bromine, also they could be included, or they could carbon atom if organic compounds could be bonded to them. So that's lead to a long variety. So imagine, guys, here that you have carbon which is able to bond to itself, and it's able to bond to these different elements: oxygen, hydrogen, nitrogen, phosphorus, okay. Imagine how could you form, or how many atoms that could you how many compounds that could you form if you try to make like a puzzle by using these atoms. You have infinity number of these atoms, and you can arrange them in whatever the way you like, okay. So that will lead to infinity. It's look like the alphabets of the alphabets of English. For example, we have 26 letters. If you just arrange them and use them in different way, you're gonna create millions of words. So that's the same here. These atoms, once they are arranged and combined in different numbers and in different arrangements, that create each time a new compound, which lead to a huge variety. So the third thing, which is the arrangement of atoms. So what I mean with arrangement of atoms? Actually, for example, look here, guys, C2H6O, that is a molecular formula. Molecular formula, that means the formula which just indicate the time of atoms and the number of atoms in a chemical compound. So C2H6OH. Here it means that we have two carbons are bonded to 6 hydrogens and 1 oxygen atom. So what is this? Actually, we could find here this could be more than one compound because by this number of atoms we could arrange it in different ways. Let's take an example to clarify the idea, or let's see. So for example here, this C2, they could be like this, CH3, that means a carbon is bonded by 3 hydrogen. Then here an oxygen atom in the center and another, okay, carbon with 3 hydrogen. So if we just check, there are 2 carbons, 6 hydrogen, and 1 oxygen. Is it right, guys? Is it right here?
Yes.
Yes. So we call this dimethyl ether. Okay, so it's an organic compound. We call dimethyl because CH3 is a methyl group. So CH3 and CH3, they are dimethyl, and O in the center here we call it ether. So dimethyl ether. Okay, and also the same C2H6O could be like this. Okay. So if we just check here, so the R, that's H here and H here. So there are also 6 hydrogen, 2 carbon, and 1 oxygen. That is ethanol, okay, or that's either the ethyl alcohol, which we use nowadays a lot, okay, in sanitizing our hands, okay. So both they have the same molecular formula. That means both they have the same number of atoms, but actually they have different arrangement, and these different arrangements make them have different and entirely complete different characteristics and properties. Alcohol is completely different than ether. Okay, they are different in the melting point, in the freezing point, even in the state sometime. Okay, and smell and color. Okay, so on. A lot of properties could be changed. Okay, regarding to the arrangement of the atoms. So if we have two compounds, okay, that they have the same molecular formula, but they have different structural formula, that means different arrangement in space, we call them isomers. We call them isomers. So that means ethanol and dimethyl ether, both of them, or they are considered isomers. Why they are isomers? Because they have the same molecular formula, they have the same number of atoms bonded together, but okay, they have different arrangement in space. Is it clear here, guys?
Yes.
Is it clear, guys? Any question till that moment?
No.
Okay. So here like this, that leads us to know more about the structure formula. Okay, so what is a structure formula? Okay, so actually structure formula, as we said, it's just represent indicates the number of atoms and the type of atoms and how they are arranged or bonding together, how they are arranged in space. Okay, how they could look like. Okay, so let's get another example here, like C4H10. Okay, 4 carbons with 10 hydrogens. These 4 carbon and 10 hydrogens, they could be arranged in different ways. Okay, for example, here, as you could see, okay, that's CH3 and then CH carrying another CH3 and CH3 in the end. So they are 4 carbons with 3 hydrogens. Okay, so in that case, okay, we call that is a structure formula. We could have another structure formula for this. We could make a chain out of 4 carbons. Okay, for example, okay. So in that case, no problem. Like here, as you can see, the C4H10 can be like this, and in that case we call this methyl propane, and that's here we call this butane. Okay, so they are isomers, okay, because they have the same number of atoms but different arrangement. So what are the kind of isomers? We're going back later, but here we just talk about the structural formula. That means the formula which show the kind of bonding between atoms and how they are arrangement. So like this, we show here that the 3 carbons are bonded together and the 4th carbon is bonded to the 2nd carbon in the middle, and each carbon already carrying a hydrogen atom like this. Okay, sometimes in the structure formula we didn't write hydrogen, just make a sign, a signal, like for example like that. Okay, we make it like this, C, okay, like that. Okay, just make it an empty like this. Okay, so that is C2H6. So even if we don't write hydrogen, it means there is hydrogen here. Okay, so it's just kind of simplification or just kind of shorthand. Okay, because already hydrogen is the most abundant element that is compound or bonded to carbon in organic compounds. So sometimes hydrogen are not formed like this. Sometimes we start to summarize that mean here. Okay, they are carbon carrying 3 hydrogens, so we can say CH3. And this CH3 is bonded to the second in the middle. This one in the middle is carbon carrying 1 hydrogen and carrying another CH3. So we say it's bonded to a carbon CH, that's one here. This one has a branch of CH3. And finally, the other side, another CH3. So that's also considered as a structure formula. So the structure formula could be written in that way or in that way. Okay, both they are the same. Okay, both represent the type of atoms and how they are arranged in space. Even if we didn't write the hydrogen, that means hydrogen is already found. This just empty dash means it's connected to a hydrogen. Is it clear here, guys? Is that clear, guys? Guys, grade 11. Is it clear? Okay. So then we pass to the next part, which is the isomers. Okay. So we said we have isomers. They are compounds which have the same molecular formula. That means they have the same types of atoms and the same number of atoms, but in different arrangements. So we have two types of isomers. We have something called structural isomers, and we have the geometric isomers. So what the difference between them? Structural isomers, guys, it means, okay, as we just explained before, they are two compounds which have which we call the constitutional isomers, okay? So constitutional isomers, it's the same meaning of structural isomers, which means they have the same number of atoms, but in different arrangement. Like C4H10, they could be just a long chain of 4 carbon atoms, as we can see here, and in that case would be called butane. Or it could be just a chain of 3 carbons, and the second carbon in that chain is already carrying a methyl group or carrying the 4th carbon atom. So in this case, we're gonna call it, okay, methyl propane, okay, because a methyl group is just attached to a chain of 3 atoms only, okay. So like here, guys, we could find both they have the same number of atoms, both contain 4 carbons, 10 hydrogens, but different arrangement make them different properties, so we call them R isomers. So in that case here, guys, if we just make a little comparison between these two compounds to find out their properties, so that for example the butane, its melting point is negative 138, while the methyl propane is 100, okay, negative 159. And here the boiling point also 0.5, okay, while here minus 11.6. So as you, and the density of course is different. So like this, although they are the same number of atoms, but the arrangement in space or how they are arranged or they make them two different compounds with different physical and chemical properties. The second type here, okay, for of isomerization or isomers, okay, is the geometric isomers. So what mean by geometric isomers? Okay, geometric isomers actually means two isomers, okay, they already arranged in the same order, okay, of bonding. That means they have the same bonding order, okay, but the arrangement in the space, or we said that means their orientation of atoms are different. For example, here we're gonna find that both they have the same number of atoms, okay, which is C2, okay, H2Cl2, okay. So like this here we have, they could find in two different arrangements. So they could be 1,2 dichloride or dichloroethane, or they can be, okay, here 1,2 dichloroethane. So what difference could be like this? 1,2, that means in carbon number 1 they are chlorine, so that's in carbon 1, and carbon 2 they are 2 carbon atoms, one for each, okay. So that's why we put 1,2 dichloroethane. But here's the problem: these two carbons may be in the same orientation, that means both in the same side like this, okay. So in that case we call that as a cis 1,2 dichloroethane, okay. But maybe they are in opposite orientation, that means one chlorine atom, okay, just in that side, while the other one in the opposite side. So we call this trans, okay. So here trans and cis, they just represent, okay, how the orientation of atoms, okay, in the two compounds that they have the same structure, isomers or structure formula. That means they have the same bonding of atoms, but in different orientation. Like this, guys, we end our first section of chapter 22. Okay, it's too easy. Just we need to find what meaning of isomers, what are the two types of isomers, what definition of organic compounds, what are the reasons which make, okay, this variety of organic compounds, and so on. So this section review will be your homework. I'm gonna wait your answers, okay, through the mail of SMS. And if you have any, study this part very well from your textbook. And if you have any question, I'm waiting to hear your questions. Any hard question here, guys?
No, Mister.
No.
So do you have any question before we end our meeting?
Thank you.
Okay, guys, thank you.